Okay students, class 10. Today we are going to study about reactions, different chemical reactions, especially displacement reaction and double displacement reaction. So let us start. This is chemistry class 10 syllabus, the first chapter, different types of chemical reactions. Actually, when we talk about chemical reactions, then there are some reactants which reacts to form products, and maybe during these chemical reactions there could be color change, there could be evolution of gas, there could be precipitate formed, or there could be new compound formed. Sometimes it could be exothermic reaction where heat is evolved. Sometimes it could be endothermic reaction where heat is required. State change takes place, and this all happens, and we say that there is a chemical reaction. Earlier also, in one video I explained about combination reaction and decomposition reaction. Today we are focused to understand displacement reaction and double displacement reaction. So to understand displacement reaction, so what is actually displacement reaction? When one element which is more reactive, or maybe which is placed higher in the reactivity series, you can ask what is reactivity series? Here you see activity series of metals, or it is also known as reactivity series of metal. The top of the series, the elements like potassium, sodium, calcium, these are more reactive, and as we move bottom, from top to bottom, reactivity decreases. So that is the meaning reactivity series. So we can say reactivity decreases when we move from top to bottom. Like gold is least reactive and potassium is most reactive. So reactivity decreases from top to bottom. Actually, this will help you to understand displacement reaction, how displacement reaction occurs. Actually, we will understand that how this activity series is prepared also. To prepare activity series, generally it is taken into consideration that which metal can readily lose their electron to form positive ions. Like potassium can readily lose their electron, valence electrons, in comparison to sodium. So potassium is more reactive than sodium. Sodium will lose electron, valence electron more easily in comparison to calcium. Similarly, we can say iron loses electron more easily than lead, Pp. So iron is placed above in the reactivity series above lead. So you can see in this reactivity series, because to understand displacement and double displacement, especially displacement reaction, we should understand activity series of metals. There is activity series of non-metals also, but this is important and this is in our concern. You can see above hydrogen some of the metals are placed, and some of the metals are placed below hydrogen. So what is the reason why some of the metals are placed above hydrogen and some of the metals are placed below hydrogen? That is also very important. If any metal can displace hydrogen from acid, Like if we are reacting magnesium Mg with HCl, then magnesium will replace H to become magnesium chloride and hydrogen gas we obtain. So here in this reaction what happens? In this reaction, the reaction of Mg plus HCl, we are getting MgCl2 plus H2 gas. This H2 gas is evolved. Here Mg is replacing this hydrogen. Okay, Mg is replacing the hydrogen. So Mg is placed above hydrogen in the activity series of metals. Hydrogen is not a metal, but it has the property of losing electrons to become hydride. So it is kept in this series. But this reaction could not happen with copper or with mercury, with silver. Silver cannot displace hydrogen from HCl. So silver is below hydrogen in activity series of metals. Okay, now let us learn some of the reaction of displacement. We can say displacement reaction. In displacement reaction, generally one metal substitutes from the compound another metal. So let us take one example, few examples, like zinc. When zinc granules added in copper sulfate solution, the original color of copper sulfate solution is blue. Then what happens? This blue solution becomes colorless because zinc displaces copper and becomes zinc sulfate. Zinc sulfate is formed. A zinc sulfate solution is colorless. So from the color change also we can point out that the reaction happened, displacement reaction happened. Copper is obtained as precipitate and deposited. Reddish brown copper deposits at the bottom of the beaker. So this is the best example to understand displacement reaction. You can see why zinc displaces copper. You can see here. In the activity series, what we see, zinc is above copper. So if any metal above any other metal, then zinc above than copper will displace copper from its compound, copper sulfate compound. So blue solution of copper sulfate becomes colorless solution of zinc sulfate. So few more examples we can consider. It happens with iron also. When iron Fe is iron granules is put in the beaker of copper sulfate. Copper sulfate. Then this blue solution becomes green and iron sulfate is formed. Iron sulfate, ferrous sulfate is formed. And copper again we obtain as precipitate. So this is also that iron is placed above copper, you can see, in activity series of metals. So this reaction occurs. But if we will place copper in iron sulfate, then no reaction will occur. Similarly, silver nitrate solution, and if you are placing copper in silver nitrate solution, so what will happen? Silver nitrate solution, which is colorless solution, okay, it becomes blue solution of copper nitrate. So what we obtain is that silver we obtain as precipitate, and this colorless solution becomes blue solution. Blue copper nitrate solution we obtain. So this color change also says that displacement reaction occurred. Here you see copper displaces copper, copper displaces silver, and so in the nitrate we got copper nitrate. We can balance this reaction. Okay, so some examples more we can give. Some more examples, like if you are providing ferric oxide and aluminum, you know both are solids, ferric oxide and aluminum. Aluminum will displace iron from ferric oxide. This is also known as thermite reaction. This is exothermic reaction. Okay. So Fe2O3 aluminum, we are getting aluminum oxide because aluminum is more reactive than iron, and we get ferrous iron as precipitate. This is exothermic reaction. This is also known as thermite reaction. This is used in joining the railway tracks. Okay, this is very important. This is known as thermite reaction. So there could be many examples of this displacement reaction, but we have to consider one thing always, that wherever displacement reaction occurs, then one metal which is placed above the hydrogen or higher in activity series displaces the metal which is placed lower in the activity series. This is always true. Another example, copper oxide. Copper oxide. If you are putting magnesium ribbon in copper oxide, then the magnesium displaces copper. Copper we obtain as precipitate. What is the meaning precipitate? That is very important. So, copper oxide, CuO, magnesium powder. Okay, precipitate means it is actually displaced. So, in the beaker, the solid form obtained, that is called precipitate. So, generally in displacement reaction, we get precipitate of displaced metal. Okay, iron displaced, silver displaced, copper displaced, copper displaced, copper displaced. Okay, actually when we talk about iron with HCl or magnesium with HCl, this is also displacement reaction, release of hydrogen. Okay students, now we'll try to understand about double displacement reaction also. So let us understand some of the reaction of double displacement. You can note down this activity series from this video, and all this you note down in your copy and mug up the chemical reactions. These are important chemical reactions. Now we learn double displacement reaction, few reactions. What is the meaning double displacement? Here, two compounds in which the metal concerned is there displaces each other. Like if you are talking about double displacement, silver nitrate and sodium chloride. Okay, what happens? Okay, think about this. Think about this reaction. AgNO3 and sodium chloride. So what we see actually in this reaction, these two compound where silver is involved and sodium chloride is involved displaces one another. Okay, now you can see here silver displaces sodium, so silver chloride, and sodium displaces silver, so sodium nitrate. Silver nitrate, sodium chloride, we obtain silver chloride, and sodium nitrate. So this type of reaction is called double displacement because both metal displaces each other. Sodium displaces silver, so becoming sodium nitrate. Silver displaces sodium, so becoming sodium chloride. So double displacement. So another example of double displacement, lead nitrate. Plus potassium iodide. Okay, lead nitrate plus potassium iodide. We are getting lead iodide plus potassium nitrate. So this lead iodide has color yellow. It has color yellow. So yellow precipitate is obtained. This is also double displacement reaction. Potassium displaces lead, potassium nitrate forms. Lead displaces potassium, lead iodide forms. So this type of reactions are quite common. That is known as double displacement reactions. Okay students, we will learn more reactions in next video. Okay, thank you.